So in this video, we'll talk a little more about the properties of exponents. Okay, so properties of exponents. Basically, everything goes off the fundamental theorem of counting. So you have the product rule, okay, and the product rule states this. If you have an exponent taken to some power, let's just say n, and a is any number, and then you have another exponent of the same base taken to the power n, this is the same thing as a to the m plus n. An example would be like 2 cubed times 2 squared is the same thing as 2 times 2 times 2 times 2 times 2. Well, if you remember that exponents are the same thing as a repetitive multiplication pattern, so you take a number and keep multiplying itself by itself, whatever your power is to the power number times, this becomes 2 to the 3 2's plus 2 2's. So it becomes 2 to the 5th power, which if you look at it, you've got 3 times that occur here and 2 times that occur here. Well, you have 2 taken to the 5th power. You have 2 to the 5 times power. So it's 2 to the 5th power, which will equal 32. Interesting. So that's one power, okay? The quotient rule, the product, this is for multiplication, by the way, this is for division. The quotient rule is the opposite of addition. Quotient rule is whenever you divide two numbers. So if I have a to the m power divided by a to the n, and they both have the same base, then this is the same thing as a to the m minus n. Okay, so let's look at 2 cubed. Well, let's do 2 to the 5th divided by 2 cubed. This is the same thing as 2 times 2 times 2 times 2 times 2, all divided by 2 times 2 times 2. Well, if you remember, anything divided by itself becomes 1, so you can cancel out 3 2's. And you're left with a total of 2 left over in the numerator, and 1 on the bottom. So you get 2 times 2 over 1, which is 2 times 2, which is 4. Now, another way to apply this method would be, hey, this is the same thing as 2 to the 5th power minus 3 equals 2 squared, which equals 4. Wow. That's a lot less work than showing all of the steps, but this is the quotient rule. Okay? The power of a power expands it. Okay, so this is called the expanded power rule or power of power rule. A lot of people like to use power of power rule because they think it's fancier, I guess, but another way to do it is called the expanded power. Okay, basically, if I have a to the m power taken to the n power, this becomes a to the m times n. Okay, basically what I mean is if I've got 2 squared cubed, this is the same thing as 2 times 2 times 2 times 2 times 2 times 2. I've got 1, 2, 3. Well, that's the same number here. In other words, if you look at it, this is the same thing as 2 taken to the power of 2 times 3, which is, how many 2's do you got? You got 1, 2, 3, 4, 5, 6, which is 2 times 3. So 2 to the 6th power, which is 64. So that is, those are some of the fundamental theorems or fundamental rules and properties that you have for exponents. This is basically, if you wanted to talk about this is exponent. So what I like to do in terms of that in writing is a m n power. Okay, so that would be another example. Okay, let's talk about power of a product rules of exponents. Okay, so there's another property that pops on. So I'm about to erase this, so if you need to come back to it, you can just pause the video. But we got some other properties that do occur. We'll talk about it as soon as I get done here. Oh, it's going to take forever to erase. But basically, you guys get the gist. Hopefully I can get these little bitty spots off. Alright, well that'll have to do. I'll do another one. Okay? The other rule that I like to talk about is power of a product. Okay? And power of a product is not hard to understand, but for some people it is who are not in love with math. Power of product rule. And basically what that means is if I have some A times B taken to the m power, m gets distributed to both exponential bases. Okay, so this becomes A to the m times B to the m. M gets distributed to both numbers. So for example, if I have 2 times 3 taken to the m power, this becomes 2 to the m power times 3 to the m power. If this was 2 times 3 squared, this is the same thing as 2 squared times 3 squared, which is equal to 4 times 9, which equals 36. Now, you could go ahead and simplify this as well. This is 6 squared, which is 6 times 6, which, hey, does equal 36. But basically what it does is it finds those numbers in between such that it's not a maximum or the minimum, which would be the least common multiple of 36, and it's neither the max or the min of 36 in terms of common factors. And so what it does is it finds those common factors in the middle, and you don't have to worry about following your order of operations right there to take care of it. You can, but you can basically apply the rule because it is multiplication. Now, you cannot do that with addition. You cannot say, hey, 2 plus 3 squared equals 36. You cannot do that, okay? You cannot say that you'll get 2 squared plus 3 squared. That does not work, okay? Now that will, it doesn't work. They're not equal, okay? Because that's a common error that people make. And remember that you've got to add them, okay? You've got to follow your order of operations. So this actually becomes 5 squared, which becomes 25, okay? 2 squared is 4 plus 9. 4 plus 9, 13. 13 does not equal 25. So that is a common error, okay? So error, watch out. So hopefully this helps you understand the properties of exponents.